Hi everyone, sorry I can't be there with you today. Here is a run through of the presentation that we would have done in class together, as well as giving you time to stop and pause and do the sheets as you go along. So hopefully this will make up for the fact that I'm not there with you. I know it's not the same, but if you do have any questions and get stuck at any point during this lesson, do jot down the questions you have and then email them over to me, and I will do my best to answer as many as I can via email. So let's get started. So to start with, we are going to be thinking about power. So you will have done power in Key Stage 3. And the equation that you will have seen for that is energy divided by time. And the reason for that is the definition of power is the rate that energy is transferred. You also hear this sometimes called the rate that work is done. So remember, work done is also energy. So you do need this definition. And you do need to remember the original equation that you will have done at Key Stage 3. Obviously, we are actually looking at this in terms of electricity. And therefore, we will be looking at another equation for this as well. But just want to do a quick recap of this equation so that you're confident putting this into practice, because often you'll need to use this equation first and then apply it for an electrical situation. Notice the units here. Power is in watts, capital W for your unit, but the actual letter that you use in your symbol equation is a capital P. Okay, so here is an example. If you have a weightlifter that picks up a mass from the floor to a certain height, what would his power be? Now you've got to remember the equation for gravitational energy to answer this question. So pause now, see if you can have a think of what that equation is. So the equation that you need to find the gravitational energy is mass times gravitational field strength times height. So looking back at our question, our mass was 145 kilograms. Our gravitational field strength is 9.8 newtons per kilogram, and our height is 1.3. So multiplying those three numbers together, what you will get is 1,847.3 joules. So that's the energy, but remember, power is energy divided by time. So our time it took for him to do that was 0.7 seconds. So what would his power be? Have a think. So we're going to divide 1,847.3 by our 0.7, and it will give us 2,639 watts. Now we can also put this in kilowatts, so remember, kilo, whenever you see kilo in front of something, that means that it is 1,000 of that unit. So to convert from watts into kilowatts, you have to divide by 1,000. Hence it being 2.639 kilowatts. Okay, so here is another question. Pause now and have a go at that on some lined paper. So running through the answer, hopefully you have done this step by step, showing all your working out. Remember, working out is important. It will get you marks. So potential energy, or gravitational energy, for both of the children is going to be your mass times gravitational field strength times height. Because they are different masses, they will do different energies. So pupil A was 3,822 joules and pupil B will be 3,528 joules. So now we've got our energy, we have to find the power. So remember, power is energy divided by time. So pupil A did it in 4.05 seconds, so their power is going to be 943.7 watts, whereas pupil B did it in 3.9 seconds, which gives them 904.6 watts. Now notice, even though pupil B did it in less time, because their mass is so much smaller, actually when you do the calculation, pupil A is the more powerful one. So it's important that you do show your working out, do show your calculations, because actually it might not be the answer you are expecting. So next you're going to have a go at a worksheet, so pause now, have a go at this worksheet. I reckon it probably will only take you about 5 minutes, so keep an eye on the clock, make sure that you don't spend too long on this. Okay, going through the answers to that sheet then. Here are your answers. You need to make sure you go through those, double check them, mark them in a coloured pen, and correct anything that needs correcting. And as I said at the beginning, if you need to email to ask any questions because you don't understand how that happened, then please do let me know. So last little bit, before we have a think about the electrical power, is having a go at this keyword unscramble. So here's some keywords. The letters are all jumbled up together. See if you can work out what each of those are. 30 seconds, go. Okay, so hopefully you got the first one at least. That one is power. Our second one is energy transfer. Third one is work done. Fourth one is the joule, remember the unit of energy. And our last one is watts, the unit of power. So when it comes to electrical power, we have a second equation, and that equation is power is equal to current times potential difference. Now, those of you who have got your notes in front of you or those of you may remember that the equation for the energy transferred in an electrical circuit is equal to ITV. So energy is equal to ITV, and so energy is equal to current times time times potential difference. So if power is equal to energy divided by time, then that tells us that current times potential difference times time divided by time will equal power. And so we can just cancel out those two time values. So all you have to remember really is that power is equal to current times potential difference. That is how you can move between the different equations. Now, you also know the formula that potential difference is equal to current times resistance, V equals IR, and therefore you can actually rearrange and substitute in values to get two different versions of the power equation, which are shown on this slide. So power is equal to current squared times resistance, and power is equal to potential difference squared divided by resistance. Now, you will occasionally have to use these in your exams. The power equals current squared times resistance is the one that is more common in combined science. So next you are going to have a go at this sheet here. So work through that one, and then once you have finished that one, so 9g.3, you are going to have a go at these two. Any of this that you do not get finished, you should finish for homework. So 9g.4 you have to finish, and then 9g.2, which I believe will be on the back of the sheet, but it may have been printed separately, is an extra sheet where you can practice using this equation more. So have a go at those, and I will release a second video going through the answers to those in a couple of days' time. So hopefully this has been helpful for you all. As I said, do email me if you have any questions or need any help. I'm not in school, but that doesn't mean that I'm not here to help you all. So please do let me know. Okay. See you all soon. Bye.